Okay, we're going to start this last little bit of chapters with actually chapter 12, section 6. Okay, we're going to talk about surface area and volume of spheres and hemispheres. Okay, so spheres are it's a solid that is the set of all points in space that are equidistant from a given point. Okay, just like in circles, that distance from the center to any point is the radius. Okay, we still have chords, we still have diameters, and we can still have tangents. All right, but the really important one for surface area and volume is the radius. Okay, and then this right here, any cross section, which if we were to like cut through a sphere, that passes through the center. All right, I'm going to do this in pink here. All right, so like this here, this cross section is a circle and it passes through the center. That's actually called the great circle. Okay, and that's going to come into play when we talk about hemispheres. All right, but to find the surface area of a sphere and the volume of a sphere, the only information that we need from our picture or from the problem is going to be the radius. Okay, surface area is 4 pi r squared. All right, and the volume, whoops, not surface area again, my apologies. The volume is 4/3 pi, and not r squared, but r cubed, okay? Surface area, we're taking a 3-dimensional object and we're gonna like cut it open and lay it flat. So for spheres, think about like you're gonna take the leather off of a baseball and lay it flat on like a plane. Okay, but volume, that is how much space it takes up. Okay, so surface area, we're just measuring 2 dimensions, but volume, we are measuring in 3 dimensions. And so that's where we get the difference between the r squared and the r cubed. Okay, so this first example, we are given the radius. All right, and so we're just going to take that radius and put it into both of our equations here. All right, surface area, 4 pi times 6 squared. All right, 6 squared is 36, and 4 times 36 gets us to 144. So the exact surface area is going to be 144 pi square centimeters. All right, remember surface area is still in square units. But if we were to get an approximate answer, this would be about 452.39. Okay, get used to practicing both exact answers and approximate answers. Okay. Next is the volume of the sphere. So again, since we've got the radius, we're just going to put that radius in to our volume equation. All right, now 6 cubed is 6 times 6 times 6. That's 216. And 4/3 of 216, you can multiply by 4 and divide by 3, is 288 pi centimeters cubed. Okay, as an exact answer, that is about 904.78. I'm sorry, approximate answer, cubic centimeters. Okay, so with the pi symbol in the answer, that's not actually multiplied. We are multiplying, but we want the exact answer. Okay, anytime we round, that's going to be our approximate answer. Okay. Number 2, the only difference is we're actually given the diameter. All right, the diameter of this sphere is 22. And just because we're in 3 dimensions, that's not going to change. To get to our radius, we divide by 2. Okay, so our radius is 11 feet. All right, and I want you to go ahead and try to find the surface area and the volume for example 2. And if you've got questions, we can talk about it in class. Okay, number 3, we're actually going to work backwards now. So we're given the volume. I'm going to set our volume equation equal, oops, forgot some stuff there, some kind of important stuff, equal to this volume that we're given, okay? All right, now the first thing I'm going to do is go ahead and get rid of the fraction, so multiply by the reciprocal. And when I take that approximate volume, I get pi r cubed equal to 2,859 point, we'll say 547, 546 repeating. Okay, since this is pi times r cubed, I'm going to divide both sides by pi. Nine 10.22. Okay, now to undo a cube, when we have, if we had squared, we would do the square root to both sides. Okay, with a cube, we're actually going to find the cube root. Okay, but another way to think about that is to raise something to the 1/3 power. Okay, and we can talk about this in class more. But that answer, our radius, if we take the cube root of both sides, is about 9.69 inches long. Oops, that's meters. Okay. And we're going to get into hemispheres. All right. A hemisphere, you are cutting a sphere right in half, right through the center. Okay. This is going to be a closed solid. And so when we think about a whole sphere is 4 pi r squared, if we cut that in half, that's 2 pi r squared. Okay, but for hemispheres, we want to include the great circle, which is like kind of the lid. So we're actually going to add another pi r squared. All right, so surface area of hemispheres is 3 pi r squared. All right, but volume, we don't, that's just how much space it holds. So we are cutting that volume equation in half, which gives us 2/3 pi r cubed. Okay. So here we go. First one, we're given the diameter. And we don't need the diameter, we need the radius, so we're going to cut that in half. Nope, that's the wrong variable. Okay. For surface area, three pi times our radius squared. Okay, 6 squared is 36. 36 times 3 gives us an exact answer of 108 pi square feet. All right, which is approximately 339.29. All right, but volume, we're going to take 2/3 pi times our radius of 6 cubed. Okay, again, 6 times 6 times 6 is 216. And 2/3 of 216 is 144. So our exact answer would be 144 pi cubic feet. But the approximate would be 452.39. Okay. I want you to try that second example on your own. Okay. You're given the radius, so you don't have to do anything, but put that number into the equations. Okay. Last two examples here. We actually are going to start here with the area of the great circle. Okay, so if you start with the area of the great circle, remember that's just a circle. So we want to set that equal to pi r squared. Okay, divide both sides by pi. If our radius squared is 36, that means our radius is 6. That's a very popular number today. And to find the volume of a whole sphere, 4/3 pi times that radius cubed, which gives us a total volume exactly of 288 pi cubic centimeters, or approximately 904.78 cubic centimeters. Okay. Again, great circle. We've got the circumference now. Okay, circumference is 2 pi times the radius. So we're going to set that equal to the circumference we're given. When I divide both sides by 2 pi, that tells me my radius is 12. Okay, and we want surface area of a hemisphere. So we're going to take 3 pi times that radius we just found squared. 12 squared is 144. 144 times 3 gets us an exact surface area of 432 pi, but an approximate surface area of 1,357.17. Okay, so again, just remember, surface area and volume, we're both dealing with three-dimensional solids, but it's a matter of, do I want to know how much area this 3D shape would take up if I lay it flat, or do I want to know how much space it will hold? Okay, and for spheres and hemispheres, the great circle is like going to be the lid of a bowl. Okay, it's still just a circle, but it just passes through the center of that hemisphere or that sphere.